Physics Bites.
Physics Bites.
A science podcast in English by the students of Notre-Dame d'Ascension.
Hello and welcome to Physics Bites, the English language physics podcast of the students of Notre-Dame d'Ascension here in Paris. This week we have a new episode from our junior level students working on their New Energies project. We have 4 students who are going to talk to us about hydrogen as one of our future sources of energy, one of our future energy vectors, and we're going to learn a lot about that. So I'm going to let them introduce themselves. We have...
Hi, I'm Lucy.
We have Lucy.
I'm Juliette.
We have Juliette.
I'm Sara.
Sarah.
And I'm Solene.
And Solene. And you guys have all 4 been with us since last year when we went to Denmark to visit the offshore wind turbines and then the whole wave energy stuff. So it's a continuation of all the stuff that you guys were doing since last year. So let's get started. You guys are working on hydrogen. Who wants to start to tell me about what we mean by hydrogen? How is it a future source of energy? What are some of the properties? What's good about it? What's bad about it? We're going to do the whole tour of the topic. Who wants to get started?
So
Juliette?
Hydrogen is the lightest and most abundant element in the universe. So as we know, it only has 1 proton and 1 electron. So it has a very high gravimetric energy density. Mm-hmm. So it can contain a lot of energy per unit of mass. It's about 142 megajoule per kilogram.
Okay.
However, it has a very low hydrogen's gravimetric energy density, so we need to solve this problem by liquefy or compressing it, as we will see later. And
so we mean by liquefying, so make it go into a liquid state, which would require very low temperatures.
Yes, and a lot of energy.
And a lot of energy to do that. Or the other solution would be to have it as a highly compressed gas, which also uses a lot of energy to put it into a high pressure state. Okay. Do we use hydrogen currently as a source of energy? Solene?
So we can use it like for the industrial, like for example for the spacecraft.
Okay.
And also for the planes, but it's only 1% of the use, and so it was using for the first time for the Apollo program. So for the first launch, it was for the Saturn V, and it's better because it's 120 megajoule per kilogram, so it's 3 times the kerosene efficiency.
Okay, kerosene being what we use usually for example, airplanes or a lot of this type of fuel.
Yeah, so it's a really high energetic density. But also we can use it for the production of fertilizer for the ammonia productions.
Mm-hmm.
And so it's with the reactions of the hydrogen and the nitrogen, and they're going to be split, and so it's going to create the fertilizer. So the ammonia.
So those are more uses of it that we have in the chemical industry. Let's try and stay focused on the energy aspect of it. So if I summarize quickly, we do use energy as a source of energy, hydrogen, but not that much. It's very specialized kind of uses.
Yeah.
But there's a lot of, I think you guys mentioned, there's a lot of will from a lot of politicians and scientists to use it as a more current form of energy, more diverse uses of it.
Like for example, we can use it for the Toyota Hybris, which use hydrogens, and so it's like really.
And we see it even around town, like buses, which are with the label on the side uses liquid hydrogen. I know that in France we're trying to have a future where we're going to become one of the main producers of hydrogen. So let's get to where we can get hydrogen from, right? Because you guys mentioned there's lots of different sources of hydrogen. We can produce it. We can find it as a natural resource. So maybe Lucy, you want to maybe go over the different means of production of hydrogen that we have before we get to the pros and cons of something like this?
So we have several methods to produce hydrogen, and it can be classified according to how it is produced. So there is a color code. So we have black hydrogen, which is most which is a way that produces most CO2.
Right. So just before we go into more details, what you're saying is that the way we classify different types of hydrogen is based on how much pollution is emitted during the production of hydrogen.
Yeah.
So we compare, for example, 1 kilogram of hydrogen or let's say, cubic meter of hydrogen coming from one source compared to another source, and we're like, how much carbon emissions it would have, and based on that, we give it a color. And these colors go from black to white. And the closer we get to white, the cleaner the source of hydrogen there is. Okay, so do you want to maybe just give a very quick rundown of the different colors and different ways of producing it and which one is more or less emitting?
Yeah, so black hydrogen is produced from coal. The coal is converted into gas before being transformed into hydrogen. Then we have brown hydrogen, which is produced like black hydrogen, but with lignite.
Right.
Then gray hydrogen, which is the most common type of hydrogen today. It's 95% of the world production.
Okay. How do we produce the gray hydrogen, which you said is the most abundant?
It's by steam reforming of methane.
Okay. So you do have to have access to a fossil fuel, and that's one of the reasons it's very emitting, because you still have to be using methane, and there is a reaction behind it to produce the hydrogen from it, which produces some carbon emissions as well.
Yeah.
Okay.
It emits around 10 tons of CO2 per ton of hydrogen produced.
Which is a lot.
Yeah.
Okay.
Then we have blue hydrogen, which is produced exactly like gray hydrogen, but the CO2 produced is captured.
Okay.
Then there is turquoise hydrogen, which is produced by methane pyrolysis.
Which is a chemical reaction, which is much less emitting carbon emissions than other forms of reactions.
Yeah.
Okay.
Then pink hydrogen, which is produced by the electrolysis of water.
Okay. What is electrolysis of water? Just very quickly. We're going to study that next year in physics, but in the meantime.
It's a method that break water molecule into molecule of hydrogen and molecule of dihydrogen and dioxygen.
And you need to bring energy in order to do this, right? You have to bring an electrical current that breaks the molecule, and based on how you produce that electrical current, you will be emitting more or less carbon, right? But exactly. if the electricity used is very clean, then this form of hydrogen would be very clean as well, because the production doesn't require too much carbon emissions. Okay.
And that's how we have green hydrogen, which is produced by water electrolysis, but with renewable electricity.
Or nuclear, I suppose.
Yeah.
Okay, and then finally,
white
the cleanest
hydrogen,
of all?
which is the hydrogen in its natural form.
Okay, and where would we find that?
We find that in a few deposits.
Right. So this is when we go like the way we would search for oil or for gas, natural gas, like methane. There are places where there's like, pockets of, I guess, hydrogen is what you're saying. And then there you're almost emitting no carbon getting access to that.
Yeah.
Okay. I think we have some of that in France. We have a couple of big resources of that, I think, in France. Okay. So that's interesting because I didn't personally know much about the way we classify hydrogen, but it's very important because we can't say hydrogen in and of itself is clean because it depends on how we get it, right? Okay. So maybe once we went over that, there's no necessary to go into the different chemical reactions and all this stuff. Let's focus on electrolysis, maybe. Is it good? Is it hard? Is it easy? Can we do it in high quantities?
The electrical energy used to break the covalent bond of water molecule, and this process has an efficiency of 60 to 80%, depending on the technology used. But researchers are also working on new technologies to have a higher efficiency.
Right, so higher efficiency being more hydrogen with less emissions, right?
Yeah.
You mentioned a couple of these. You talked about, for example, high temperature electrolysis.
Yes, it will facilitate the reaction
and permit higher efficiency than the traditional electrolysis, exceeding 85%.
Right, which would be very, very useful if we can manage to do that, especially if we have good, clean sources of electricity. You also talked about some biological methods of producing hydrogen?
Yeah, because researchers found that microorganisms such as bacteria and algae can produce hydrogen.
Right. I suppose that is more on a theoretical level, because to produce using biological methods on a large industrial scale, it's much more difficult, I suppose.
Yeah, I think.
Okay. Maybe we can... Yeah, Juliette?
Just in countries where there is not a lot of water for the electrolysis, researchers are working on a project that use seawater.
Okay.
So it's very complicated because electrolysis doesn't work with seawater because of the iron chloride.
All the salt that's present in, and lots of other molecules like minerals and stuff.
So they use the Lewis acid, so it's like or cobalt, but it's very controversial because it's very rare and it's very hard to take. Okay. But it could be a good hope for countries that don't have big resources in water.
Okay. And the idea would be that if we could get most of our hydrogen from electrolysis, it would be a big win for everybody because it's pretty clean. Everybody knows how to do it technologically. It's not very difficult, and it would be easy to install in great quantities. Okay. I just have one little question before we move on to maybe some of the challenges and some of the prospects for hydrogen, because I see that Sarah is waiting impatiently for her turn to contribute. We often talk about hydrogen as a good energy vector. What does that mean? Can somebody maybe try and help us understand what we mean by hydrogen is a good energy vector? I think to help you guys, we can talk about electricity. Electricity is a form of energy, right? But it's also the ideal energy vector because we can use it for transferring energy from one place to another, right? Most things might not work with electricity. Most sources of electricity are other forms of energy, but it's a good way of converting to electricity, get it somewhere else, and then use it for doing something else, right? No?
Like to stock hydrogens or...
That could be part of it, right?
Yeah, like for example, there were a project it's called the High Balance Project in Denmark. So it concluded in 2020. And so they use the hydrogens when there's too much wind turbine, with the wind turbine, when there's too much wind and they produce too much energy, the energy is going to use to convert hydrogen in water, right. So we can stock
the inverse of electrolysis, right?
And so we can stock the energy, and after we can do the hydrolysis to convert in hydrogen, and after to have energy.
Okay, so the idea being that hydrogen is not as good as electricity as a means of like maybe storing energy somewhere and then transferring it somewhere else, because transporting hydrogen is difficult, right? I think you guys at one point talked about it. We'll come back to it. Maybe Sarah will talk about that. But so this is one of the reasons hydrogen has been a subject of a lot of good speculation the last few years, is because it has these properties that make it not only just a good source of energy, you can burn hydrogen cleanly to produce heat, to produce electricity, but can also be used as a vector. Okay, so maybe we can move on to what makes hydrogen a good source of energy, what can be difficult with it. I think, Sarah, you were the one who started off most of that. So let's talk about some of the challenges facing use of hydrogen at a global scale, maybe.
So hydrogen energy is a good source of energy, but faces challenges. So it faces his low volumetric density. Even
what do we mean by that exactly? What do you mean by low volumetric density?
So because
Juliette, maybe you want to answer, because you talked about that originally. Yeah.
It can't contain a lot of energy per unit of volume.
Yeah.
So that's why I think we'll talk about it later, but it's very important to compress it. Right.
So because it is a very low density gas in general, if we just take it at like atmospheric pressure, there's very little hydrogen there. But if we want to use produce a lot of energy from it, we would have to have it more dense, which means putting it into high pressure, right? So I guess this is what you mean by the low volumetric. Okay, go on, Sarah.
So we can find different storage methods. So we have the high pressure storage. So hydrogen is compressed to pressures up to 700 bars and stored in specialized tanks. So, but this method remains costly due to the needs for reinforced tanks.
Right. Just so we're clear, 700 bars is very high pressure. It's about 700 times the atmospheric pressure, right? 1 bar is about the equivalent of 1 atmospheric pressure. So at that high pressure, we would need really strong materials, you're saying, to store this high pressure gas, and that's costly. Okay. Especially if we're going to have large quantities of it, that would mean really big infrastructure for something like that. Okay. What are some of the other challenges that face hydrogen?
So we can find the hydrogen transport. So hydrogen transport is limited because by the lack of large scale infrastructure. So hydrogen is mainly transported in liquids or gaseous form. So via tanker trucks, but so there are few pipelines specifically designed for gas. So for example, we can find one in Japan, so with the Shaiyo Corporation, which has developed a technology that binds hydrogen to toluene, a liquid organic carrier. So this allows hydrogen to be transported like conventional fuels and separated when needed.
So we're starting to see a theme here. The difficulties with hydrogen is that because of its gaseous form and its low density, storage becomes an issue. And transport is similar to storage, just like storage that's moving, right? So in both cases, we would need infrastructure which is not necessarily cheap or available in great quantities. Is there any innovation around there? I assume that there must be some stuff going on because there's a lot of demand for hydrogen. There's a growing sector. So there must be people coming up with new ideas, maybe?
So we have companies like Air Liquids, which are developing ultra-insulated tanks. So for the storage and transport that minimize thermal losses during hydrogen storage and transport. So for example, we can find the LOHC project technology. It proposes a safe and cost-effective solution for maritime hydrogen transport using liquid organic hydrogen carriers, so LOHC. So it allows secure oceanic transports of hydrogen. And so
like the equivalent of big oil tankers, but this time for carrying hydrogen in a liquid state, which means that it would be a giant boat which has a big giant hole in it with really, really, really low temperatures to put into a liquid state. Okay, go on. You talked about this new state, LHC plus, LHC minus, at one point. Do you remember what that was?
So the process comprises 2 distinct phases. Okay. So hydrogenation, so LOHC plus, enables hydrogen to be loaded into a liquid carrier. Okay. So in the state, the charged carrier can be stored or distributed.
So it's like a chemical reaction that we do, so we can sort of attach hydrogen to another molecule, which is easier to deal with, and then when we transport it, then we take it away from that molecule. Is that the idea? And what was the difference between the plus and the minus version?
So if hydrogen is required, the carrier can be discharged so independently of time and place. So this is the dehydrogenation phase, so LOHC minus.
Okay, so when we're adding hydrogen to the molecule for like at the beginning, we call it LOHC plus, and then we want to take it back to use it for whatever, then we call it minus. Okay. Remember, I wrote that down in my notes, but I didn't remember what it was. Okay. Are there any other difficulties that we're faced with if you want to use hydrogen in a more universal way? So storage, transport. Are there any dangers associated to hydrogen? Juliette is
Yes.
nodding vigorously. So, do you want to go, Juliette?
This is very flammable.
Right.
So if there is just a little leak, it can explode in a
Right.
lot of consequences.
It's highly flammable because it's a very reactive gas.
Yes.
It reacts with almost anything, and so if it's exposed to any other sort of molecule, it has the potential to have a very exothermic reaction, right? Okay.
So they need to make containers very
Safe, secure.
very secure to prevent the leak. But this is really hard, and that's why we don't have for now really long distances transport because it's too dangerous.
Right.
But it will come sooner.
Okay.
With maybe other materials.
Okay, so that is one of the main dangers of hydrogen is the fact that it could be very explosive, and so we need infrastructure which is very safe and secure. Otherwise, it could pose a big problem. Okay.
There's
yep,
also a
Solene?
problem with the infrastructures because there's not a lot of infrastructures of hydrogen.
Is there any part of the world which has decent infrastructure for hydrogen at this point, or no? You mentioned
in Paris,
Japan.
we have 14 infrastructure for the car, for the hydrogen car.
Oh, really?
Yeah.
Okay, I didn't know this. I guess it would be a big difference between developed countries and developing countries, right? So you mentioned also Japan. They have a pipeline, I think you said.
They have a power plant that works with hydrogen, but not only. It's like a mix of fuel and
Right.
hydrogen.
Okay, to produce heat and produce electricity,
Yes.
right? Okay. Do you know what kind of hydrogen they use, or what color? So just so we're clear, the color is that they don't have that color. It's a code, right?
Yeah.
It's not actually red or green or black. Okay. Yeah. And that was one of the questions that somebody had asked. Okay. Maybe we can very briefly, to finish up, talk about other uses that we have for hydrogen, which is not necessarily directly to produce electricity or other stuff. You talked about different sectors which already use hydrogen and other sectors where we have uses for it, which is not necessarily energy-wise. I think it was Solene who talked kind of about that, the different types of industrial use that we have for hydrogen, which is not just energy-based.
Yeah, like for example for the car.
Okay.
Also I talked about the spacecraft.
Right, so the space industry uses a lot of hydrogen already, but that's been the case for many decades.
Yeah, it was like I told about the during for the launch of the Saturn V and for the Apollo program. So it was I think
the 1960s.
Yeah.
And 70s. Okay. Well before you guys. All right. I think we've gone over most of the different topics that you guys brought up during your presentation. I know it's a very vast topic. Are there any things that we didn't really talk about that you want to maybe underline before we go to the end of the interview?
There's also for the productions of there's the hydrogen fuel cells and the
Right. So what are hydrogen fuel cells? That's important because we have a lot of uses for that already, and there's going to be a growing.
Yeah.
What are hydrogen fuel cells?
So it's a system chemical reactions between the hydrogen and and oxygens, which is going to create water.
Okay.
And so it's going to create energy also. The water, there's a little bit of water, and it's 50% of efficiency.
Okay.
So it's really, really good compared to the combustion of hydrogen, which is less, like it's so cheap.
So just so we're clear, you talked about, you compared hydrogen motors that use the combustion of hydrogen, and you talked about cars, for example, that run with hydrogen fuel cells, and it's not the same thing.
No. Yeah, there's difference, but
the hydrogen fuel cells that you're talking about, we're not burning hydrogen to produce heat,
it's
right?
chemical reactions,
right?
Compared to
so it's an electrical kind of engine, right?
Yeah.
Okay, and when we're talking about electrical, which means that what type of reaction is involved here? Since you guys have been doing that in physics this year,
for
hydrogen fuel cells,
it's hydrogen and oxygens.
And there's an exchange of electrons.
Oh yeah, so with a cathode and a method.
Right, and what do we call these types of reactions?
It's
redox reactions, right?
What?
Oxidation, reduction.
Okay, yeah.
What do we call reactions which involve oxidation and reduction? We call them redox.
Yeah. Okay.
In French, redox.
Yeah.
Oxydoreduction. Okay. And those, I remember when I was your age, I had my physics teacher who used to talk about these hydrogen fuel cells. He was like, yeah, in the future we're going to have cars that run on water, which basically take hydrogen and they take oxygen from the air and they make a reaction, which is not burning, and it'll, instead of throwing out dangerous gases from the exhaust pipe, it puts out water. And this was many decades ago. And we still don't have many of these cars, but I guess the buses we have that run on hydrogen, they're kind of like this. Okay. So maybe we can go to the last part of the interview. I'm curious to hear your own opinions on hydrogen. So I suppose this was one of those things that you guys didn't know much about before you did the research for this project. Maybe you'd heard of it because I know that it has been in the news recently. I'm just curious to know, what did you guys learn which was very surprising to you? By reading up and doing all this research, are you convinced that maybe hydrogen is a good solution for the future, or that it's too difficult? So we'll just maybe see what you guys think about it. Maybe we can start with Lucy.
I think it's a great thing because even if there is difficulties, we have infrastructures to have, like, to...
I don't know what you're trying to say.
Mais en gros, on a des infrastructures pour s'en occuper.
So you're saying that once we develop that infrastructure, it will become a very useful form of energy for the future.
But I think if we continue to use just like grey hydrogen, we don't use hydrogen at his advantage, which is that we have a method to use it and to not produce CO2 method, but it's most costly, so we have to work on that.
So if I understand correctly, you're saying that hydrogen has the potential to be very good and clean, but if we're using the same sort of hydrogen that we have currently, the carbon emissions are high enough that it's not going to make much of a difference. So we need to change the way we produce hydrogen, or we get access to hydrogen. Okay. Juliette, what did you think about the topic? What did you find interesting, striking, maybe?
Well, all the difficulties you need to solve to use it, and I think we are still in a period of a lot of...
We're learning about it, so let's start at the very beginning.
So the researchers are going to improve all the methods to produce it, to stock it, and then to use it. And so now it's not really useful. When we compare to fuel, it's like it emits...
it's not very feasible, and the only kind that's feasible emits just as much carbon.
But in the future, I think it will be very useful. As we saw, we can use it in a lot of sectors. But we need to make a new, to invent new method. Right,
producing it cleanly and then to have the infrastructure that goes with it. Solene, Sarah, what about you guys? What did you learn that was particularly interesting or that you found very surprising or striking during your research and preparation on this topic?
So I agree with Juliette, because I think hydrogen can revolutionize some fields like aviation, so storage and transports, and it can be very interesting to develop the methods.
Okay. Solene?
Yeah, I agree.
What did you learn of particular interest during this research?
I didn't know that much about hydrogen, and so I learned that it was really eco-friendly, but not for the production, like for the green hydrogen. But
it has the potential to be very, but it's not yet there.
Yeah, but for the example, the oxide reduction, it's really eco-friendly. It's produce only water, so it's a good way for the future to be more eco-friendly, I think. And it's already used, so that show that's work like for the planes or for the.
Okay. So we know we can do stuff with it. We just have to find ways of, again, same theme as the other responses, is that we have to find a way of getting access to it in a more clean way. I guess you can be positive and say that we don't have enough research in there, we don't have enough knowledge to use it, which means that there's a lot of stuff that we can still learn and do. So if somebody at your age wants to go into something that has to do with energy, with the technology around it, this could be an interesting field. Okay, so if you have nothing more to add, I think it was a really interesting presentation that you guys did. The topic is clearly, I think, new for most people, including myself. And so I guess we're learning about it all the time. So thank you very much.
Thank you.
Thank you.
So that is Physics Bites for this week. We hope that you enjoyed this episode, and we would love to hear what you thought about the topic in the comments section. If you did enjoy the show, then subscribe to our podcast, share it with your friends, and be sure to leave us a 5-star rating on whatever platform you're listening on. And more important than all of that, come back soon for a new episode.